So in this topic, we will be solving the derivatives of logarithm and exponential functions. Say we have, for example, log base 4 x cubed. So to solve this, we will use the formula d over dx log a log base a x equals u prime over u ln a. Then we need to identify our u prime, and our a. So u is equal to x cubed, our u prime is 3x, and our a is 4. So this will give us 3x over x cubed ln 4. So we'll cancel out x cubed and x, and this will give us 3 over x squared ln 4. And this will be our final answer. So let's have another example. Say we have x cubed ln x. So to solve this, we will use the sum rule, which is d over dx f of x plus g of x, which is equal to f prime times g plus f g prime. So let's identify our f prime, and g prime. So f would be x cubed, and f prime would be 3x, and g would be equal to ln x, and g prime would equal to 1 over x. So this will give us, by using the sum rule, this will give us d over dx 3x ln x plus x cubed times 1 over x. So this will be cancelled, and solving the derivative for 3x would be 3x ln plus x squared. And this is our final answer. So for our next example, we'll be solving exponential functions. The previous one was logarithmic functions. So for the exponential functions, let's say we have e raised to 5x. So to solve this, we'll use the formula d over dx e raised to u is equal to e raised to u times u prime. So u is equal to 5x, and u prime is equal to 5. So e raised to 5x is going to be multiplied by 5. Solving this will give us our final answer, which is 5e raised to 5x. So this is our final answer. For our next example, let's say we have 3 raised to x squared. So to solve this, we'll be using the formula d over dx a raised to x is equal to a raised to x ln a, wherein a is equal to 3. So this will equal to 3x squared ln 3, and this is the answer. So our next topic would be about the derivatives of trigonometric functions. Say we have, for example, f of x is equal to x squared plus sine x plus 3 cosine x. So what we need to do is get the derivatives of x squared, sine x, and 3 cosine x. So f prime of x would be the derivative of x squared, which is 2x, plus the derivative of sine x, which is cosine x, plus the derivative of 3 cosine x, which is 3 times negative sine x. This will give us to our final answer, which is 2x plus cosine x positive 3 multiplied by negative sine x would be negative 3 sine x. And this would be our final answer. Say we have f of x is equal to 4 cosecant x plus 8 tangent x minus 5 secant x. So we'll do the same. So f prime of x would be 4 times the derivative of cosecant x, which is negative cosecant x cotangent x, plus 8 times the derivative of tan x, which is secant squared x, minus 5 times the derivative of secant x, which is secant x tangent x. Solving this would give us to our final answer, which is 4 times negative cosecant x cotangent x would be negative 4 cosecant x cotangent x plus 8 times secant squared x would be 8 secant squared x minus 5 secant x tangent x. And this would be our final answer. So our next topic would be about the derivatives of inverse trigonometric functions. So let's say we have the derivative of sine raised to negative 1 x raised to 5. So to solve this, we need to use the trigonometric identity, which is d over dx sine negative 1 raised to negative 1 times u is equal to u prime over the square root of 1 minus u squared. So identifying our u and u prime, that would be u is equal to x raised to 5, and u prime would be 5x raised to 4. So by applying the formula, we'll get 5x raised to 4, which is our u prime, over the square root of 1 minus x raised to 5, which is our u squared. So squaring this, this will give us our final answer, which is 5x raised to 4 over the square root of 1 minus x raised to 10. So this is our final answer. For our next example, let's say we have d over dx cosine raised to negative 1 3x minus 6. So by using the formula d over dx cosine raised to negative 1 times u is equal to negative u prime over the square root of 1 minus u squared. So by applying the trigonometric identity, this would give us equals negative 3 square root of 1 minus 3x minus 6 squared. So squaring this, 3x minus 6, this will give us our final answer, which is negative 3 over the square root of 9x squared plus 36x minus 35. So this is our final answer. So our next topic would be about hyperbolic functions. Say for example we have the function f of x is equal to 2x raised to 5 cosine hx. So by applying the product rule, which is d over dx f times g is equal to f prime times g plus f times g prime. So our f would equal to 2x raised to 5 and f prime would be 10x raised to 4 and g would be cosine h x and g prime would equal to sin h x. So f prime would be the derivative of 2x raised to 5 cosine hx plus 2x raised to 5 d over dx cosine hx. So by applying the constant multiple rule, we'll have 2d over dx x raised to 5 cosine h x plus 2x raised to 5 d over dx cosine h x. So this will equal to 2 times 5x raised to 4 cosine hx plus 2x raised to 5 sine hx. And this will give us our final answer, which is 10x raised to 4 cosine hx plus 2x raised to 5 sine hx. And this would be our final answer. For our second example, say we have h of t equals sine hx over x plus 1. So for this example, we'll use the quotient rule, which is d over dx f over g is equal to g f prime minus f g prime over g squared. So f would equal to sine hx and f prime would be cosine hx. and g would be x plus 1, and g prime would be 1. So by applying the quotient rule, we'll have x plus 1 times cosine hx minus sine hx times 1 over x plus 1 squared. So this will give us our final answer, which is x plus 1 cosine hx minus sine hx over x plus 1 squared. So this will be our final answer. So our next topic would be about implicit differentiation. Say we have dy over dx 5xy minus y cubed is equal to 8. So what we need to do is find the derivatives of each of these, and finding those derivatives will give us 5y plus 5x dy over dx minus 3y squared dy over dx equals 0. So the next thing we need to do is move the 5y to the right side. So it will give us 5x dy over dx minus 3y squared dy over dx equals negative 5y. And so what we need to do is to cancel 5x minus 3y squared dy over dx equals negative 5y. So what we did was we combined 5x and negative 3y on the left side. So when we cancel this, it will give us 5x minus 3y squared minus 5x, over 5x minus 3y squared. And what we did was we need to divide both sides by 5x minus 3y squared to cancel out the 5x minus 3y squared on the left side. So this will be cancelled, and our final answer would be dy over dx is equal to negative 5y over 5x minus 3y squared. And this is our final answer. So our second example would be, let's say 75 is equal to square root of x squared plus y squared. So since there is a square root on the given equation, we need to square both sides. So even though we know that 75 would be equal to 0 later on, let's just square it. So 75 squared is equal to the square root of x squared plus y squared square root. So this will be cancelled, and let's just not give the result of 75 squared, since it will then equal to 0. So we need to get the derivatives of both sides. 75 squared is equal to x squared plus y squared d over dx. So the derivative of 75 would equal to 0, and x squared plus y squared would equal to 2x plus 2y dy over dx. So moving the 2x to the right, this will give us negative 2x is equal to 2y. So we need to cancel out 2x, so let's divide both sides by 2y. We need to cancel 2y on the right side, so let's divide both sides by 2y. So this will be cancelled, and it will give us our final answer, which is dy over dx is equal to negative x over y. And this is our final answer. So our last topic would be about higher order derivatives. So let's say we have the function f of x is equal to 3x raised to 5 plus 2x cubed minus 6x plus 4. So to get the first derivative, we need to find the derivative of each of these. So this will equal to 3 times 5x raised to 4, which is the derivative of 3x5, plus 2 times 3x raised 3x squared, derivative of 2x cubed, minus 6 times 1, wherein 1 is the derivative of x, and plus 0, where is the derivative of 4. So this will lead us to our first derivative. F prime is equal to 15 x raised to 4 plus 6x squared minus 6. So this is our first derivative. To get the second derivative, we need to then again find the derivative of 15x raised to 4 plus 6x squared minus 6. So second derivative of the function would be the derivative of the first derivative, which is 15 4x cubed plus 6 times 2x plus 0, wherein 0 is the derivative of negative 6. This will give us 60 x cubed plus 12x. So this will be our second derivative. To get the third derivative, f of x, again, we need to find the derivative of the second derivative, which is the last one. So this will give us 60 3x squared plus 12 times 1. This multiplying 60 by 3x squared will give us 180x squared plus 12. So this will be our third derivative. For the second example, let's say we have f of x is equal to the square root of x. So to solve this, we'll use the power rule, because square root of x will equal to x raised to 1/2. So the power rule would be nx raised to n minus 1. This is the power rule. So let's solve for the first derivative. So f prime of x would be 1/2 x raised to 1/2 minus 1. This will give us 1/2 x, 1/2 x raised to negative 1/2. For the second derivative, we'll then again solve for the derivative of 1/2 x raised to 1/2. So this will be 1/2 multiplied by negative 1/2 x raised to negative 1/2 minus 1. This will equal to negative 1/4 x raised to negative 3 minus 2, because we subtracted 1 from negative 1/2. So this will be our second derivative. So to get our third derivative, we'll then again do the same. So f of x is equal to negative 1/4 times negative 3 over 2 x raised to negative 3 halves minus 1. So solving this will give us 3/8 x raised to negative 5 halves. It became positive because negative 1/4 times negative 3 halves will be positive. So this will be our third derivative. And that will be all. And thank you.